Today we are going to discuss one of the most important topic, that is boiler and boiler problems. As all of you know that boiler is extensively used particularly in electrical engineering, hydropower station and mechanical engineering. Basically, boiler may be of three types: high pressure boiler, medium pressure boiler and low pressure boiler. Slowly we will go in depth. If anybody asks you what do you understand or mean by a boiler, then you have to tell it is actually a device being used to make steam, which will eventually be utilized to generate electricity. You know that. And therefore, boiler is a machine, is a device, is a container where some raw material will be put. As here, we will be using water, you know that. And during boiling, steam will be produced. Now, this steam will be used or utilized to rotate turbines, ultimately to generate electricity. That is why actually boiler is used. And therefore, for a boiler, we need some raw material. It is very similar to human stomach. You know, human body, if we consider as a machine, it has different parts. And if we want to keep all parts in active state, so we have to supply energy. And how do we do that? We take food in various form. Food particle will go into the stomach, and ultimately digestive system will work on it, and ultimately it will be converted into glucose, which is being absorbed in blood in the form of energy. This is what happens in human body, and therefore food is the raw material to make your body active. Similarly, in a boiler we are going to make steam, and therefore raw material being used here will be your water. As all of us know that if we want to keep our body fit for a long time, the kind of food we are going to take, we have to ensure the quality. Because if we do not take proper quality of water, proper quality of food, so different kind of diseases may appear in our body. Sometimes light form of disease may come, and sometimes very serious type of disease may appear. And similarly, the raw material being used in boiler, that is your water, if the quality of water is not up to the mark, different kind of problems may appear in our boiler. As all of you know that, the cost of a boiler is in crore. And therefore, if we make or purchase a boiler at the rate of, say, ₹5 crores, naturally, we will expect our boiler to go at least for 20 years because we are businessmen. We have purchased the boiler to make steam. Therefore, we have to run this boiler at least for 20 years. But because of poor quality of water being used as raw material, if some kind of problem appears in your boiler in a year or two, then we will be at risk. As we ensure the quality of food being taken to keep our body fit. So similarly, if we want to keep our boiler fit for a long time, we have to ensure that the water being used as raw material in our boiler must comply with some specification. Chemists all over the world have studied these parameters very extensively, and they have recommended a specification which being used in a boiler to keep our boiler fit for a long time. I am not going in depth as far as specification is concerned, but that much we should know. If we want to keep our boiler fit for a long time, the water being used as raw material must comply with the specification. If we comply with that specification, our boiler will go undisturbed for a long time. But if we do not comply, then problem will appear. If we comply, no problem. If do not, then problem will appear. What kind of problem will appear? Let me tell you. Number 1 is sludge. Number 2, scale. Number 3, scale due to silica. Number 4, caustic embrittlement. Number 5, corrosion. These are the different problems which may appear in our boiler if the quality of water being used as raw material is not ensured. What are they? Sludge, scale due to silica, caustic embrittlement and corrosion. Our concern is this one. But rest of the 5, that is sludge, scale due to silica, caustic embrittlement, they have also some kind of role in causing corrosion or increase the severity of corrosion either directly or indirectly. And that is why we are going to discuss one by one slowly. Number 1, let us start with sludge. To discuss sludge, let us take one example. You might have noticed nowadays we are using sophisticated kind of utensil for cooking purpose. But if you go to village, even today, you will see that they are using a special kind of container for frying something or making cooking foods. You might have seen, you might have noticed, they use this kind of thing. The name of the utensil in village is known as Corrosion, and it is basically made of iron. And if you have noticed, you might have seen, every time your mother uses this utensil for cooking purpose, every time she washes this utensil, that is karai, with a piece of wood or something like that, scraper kind of things. She does not know what she is doing. You also do not know what she was doing. But if you go in depth, if you analyze it technically, then you will understand the water she was using might have some kind of hardness, which during cooking actually has been deposited in the inner wall of the container, and she was trying to remove those impurities. Now let us see how sludge is formed. Actually, the water being used, you know, for cooking purpose, every time water will be used. Now this, if water being used for cooking, if contains magnesium salts, like magnesium sulfate, magnesium carbonate, magnesium chloride and calcium chloride, so this kind of sludge will be formed. Then what is sludge? It is actually a slimy type of material. It is not very hard, it is soft, slimy type of material. If water being used in a container, it contains this kind of soluble salt, magnesium salt like magnesium chloride, magnesium sulfate, magnesium carbonate and calcium chloride, they will be making this kind of sludge. The sludge is the deposition of simple and slimy type of material on the inner wall of the container being used for cooking purpose or in boiler. We are actually, if we understand this phenomena, then what happens in boiler will be easy for us to understand, and that is why I am taking this example. And therefore, water being used for cooking purpose, it contains magnesium salt like magnesium sulfate, magnesium carbonate, magnesium chloride and calcium chloride, will cause sludge. Then what will be the consequence of sludge? Sludge formation. Try to understand that. This is your container. This is sludge is produced every time your mother is clearing like that. Slowly and slowly, your mother is exerting pressure. That is every possibility. What will happen? If you do not remove this sludge and heating is going on from the bottom part, so heat loss will be there because thickness of the karai by utensil will get increased. That is, fuel consumption will be more, heat loss will be there, and lifetime of the container will get reduced. This is the actual consequence of sludge formation. Now, we have to see about scale. If anybody asks you how can you control sludge formation, the best solution is that we have to use water free from magnesium salt and calcium chloride. Then only sludge formation will not be there. However, water source being used, if contains this kind of salt, there are so many techniques, so many methods which can be used to remove this hardness. This is not part of our syllabus, and therefore removal of this actually sludge formation or forming impurities by hardness producing salts we are not discussing here, but there are methods, LS process, zeolite process, there are so many methods by using you can remove sludge. Now let us talk about scale. It is actually, if we compare sludge and scale, it is like that. Suppose you have got mild fever, just by taking a small paracetamol tablet, you can get rid of this temperature, small fever, you can get rid of it. But if everybody is suffering from cancer, then paracetamol will not be sufficient to cure the patient. The difference is like that here also. Sludge, I have told you, it is very simple and slimy deposition on the inner wall of the boiler or container, wherever water containing magnesium salt and calcium chloride is being used. But if scale is there, it is very, very dangerous. How it is formed and what are the sources, slowly and slowly, one by one, we will be discussing. Suppose you are using boiler in which water is being used as raw material. If the water is free from undesirable salts, there is no problem. There is no chance of sludge or scale formation. But the water you are going to use, suppose containing some kind of salt like calcium bicarbonate, it is in water. We know that. During boiling, that kind of water containing calcium bicarbonate you have put in your boiler, heating is going on, water will start boiling. What will happen? Steam will be produced, steam will go out. Now, during this process, this calcium bicarbonate will be converted into calcium carbonate plus carbon dioxide and water. You know that. And calcium carbonate is insoluble in water. Suppose this is your boiler. Now what will happen? You have taken, say, 1000 liters of water initially. For the sake of discussion, let us assume that hardness is, say, 1 ppm. You know hardness, ppm, full form of ppm is parts per million. You also know that. It is a boiler, you have taken 1000 liters of water, hardness is 1 ppm. Now heating is started. After some time water will start boiling, steam will be produced and steam will go out, and slowly water level will go down. And ultimately, suppose it has gone down to this level, when 10 liters of water is left. Initially you have started with 1000 liters, now it is 10 liters only. Heating is stopped. Now if anybody asks you, initially hardness of water you took for your boiler was 1 ppm. Now when the volume is reduced to 10 liters, what will be the hardness of this 10 liters of water? You know, concentration is directly proportional to volume. Sorry, inversely proportional to volume. If volume is increased, dilution will be there, concentration will be decreased. If volume is decreased, concentration will get increased. Let us take another simple example to make you understand. Suppose that is a glass of water. This is a glass of water and amount of water is 100 ml. I have told you, add some sugar. You will ask me, how much should I use, sir? I have told you, add 10 gram. But unfortunately, you have only 5 gram. Then what will you do? Suppose you have added 5 gram only. It will be less tasty, it's less sweet. In that situation, if I ask you, do something so that I will get the water having taste as good as 10 gram, then what you will do? You will keep on boiling. When the volume will be reduced from 100 to 50 ml only, this is 50 ml. Now, this 50 ml of water will be as sweet as it would have been if 10 gram of water you have added in 100 ml of water. What you have done? Volume is reduced from 100 to 50. Strength was, here it was 5, now it will become 10. Try to understand that. If volume is reduced by 2, strength will be increased by 2. If volume is increased by 2, strength will be reduced by 2. Try to understand that. Now here, your volume was 1000 liter. Now it has become 10 liter. How many times the volume is reduced? 100 times. Reduced. If volume is reduced by 100 times, automatically concentration will be increased. Is reduction there? Reduction is there. In terms of volume, concentration will be increased accordingly. And therefore, strength by hardness will be increased by 100 times. Initially, if hardness was 1 ppm, now it will become 100 ppm. Try to understand. Now, if the volume is reduced from 1000 liter to 10 liters, you have reduced volume by 100 times, and therefore strength by considered hardness will be increased by 100 times. It means the entire hardness producing salts that was present in 1000 liter of water is now present in 10 liters of remaining water. And if this, then what we will do? Again you will take another 100 liter of water, or 1000 liter of water, start boiling. Again volume will be reduced to 10 liter, boiling will be stopped. Now how much it will be? Another 100 will be there. It will be 10,000 ppm. So every time hardness will get increased. And due to repeated cycle of operation like that, one time will come, it will reach hardness producing, solubility of hardness producing salt will reach saturation point. You understand that? What is saturation point? You know that. If you take a 100 ml of water in a glass, and if you are asked to add sugar in it, and if you keep on adding water or sugar to it, one time will come, no more sugar will go into water. It will not get dissolved. At a particular temperature, a fixed volume of solvent can dissolve a fixed quantity of solute. That is known as solubility. And definitely solubility will be in terms of a liter. And therefore, suppose if it is solubility is for the sake of discussion 100, then 1 liter of water can dissolve maximum 100 gram of that solute. So similarly, the hardness producing salt which was present in water, they must have a definite solubility. And therefore, due to repeated cycle of operation, when they will reach the saturation point, then they will not go into solution. No, they will not get dissolved in water, and they will be deposited on the inner wall of the boiler. Now if this deposit is adhered very tightly. Try to understand that. Then it is known as scale. But if it is soft and slimy, then it is known as sludge, what I have told you earlier. Slimy kind of deposition will take place if water contains magnesium salt and like magnesium carbonate, magnesium sulfate, magnesium chloride and calcium chloride. But if water contains, as I have told you, calcium carbonate, what will happen? I have told you, if calcium bicarbonate is there in your water during boiling, it will be converted into calcium carbonate, carbon dioxide and water. Now, this calcium carbonate, being insoluble in water, will be deposited on the inner wall of the boiler. And this is known as scale. It is not soft and slimy. But one thing I would like to tell you, the deposition or scale, which is mainly composed of calcium carbonate, is not very hard. And this type of scale is found in medium pressure boiler. QK. In high pressure boiler, what happens? This calcium carbonate in high pressure boiler will get dissolved, producing calcium hydroxide. And therefore, if the scale being produced due to the presence of calcium bicarbonate initially, which will undergo decomposition, producing insoluble calcium carbonate, will be seen only in medium pressure boiler, because in high pressure boiler, as soon as calcium carbonate is being formed, will be dissolved in the form of calcium hydroxide. Now we have to see the scale due to calcium sulfate. As all of you know that. Solubility of calcium sulfate at 15 degrees centigrade, it is 3200 ppm. At 230 degrees centigrade, it is 55 ppm. And at 320 degrees centigrade, it is 27 ppm. Try to understand. It means with the increasing temperature, solubility of calcium sulfate is getting reduced. And therefore, water being used in boiler, it contains calcium sulfate. And as all of us know that, in a high pressure boiler, temperature will be very, very high. As a result of which, calcium sulfate, if initially present in water, will become practically insoluble. As a result, it will be deposited on the inner wall of the boiler in the form of hard scale. Next one is scale due to silica. The water being used in your boiler, suppose it contains silica, and if water contains calcium, then it will produce calcium silicate. And similarly, if water contains silica and magnesium, it is going to be produced magnesium silicate. As we all of us know that calcium silicate and magnesium silicate both are insoluble in water and will be deposited on the inner wall of the boiler, which will be very difficult to remove. This is all about your actually scale due to silica. How we can remove actually scale due to calcium carbonate, calcium sulfate, we'll discuss in our next lecture. Please go through the video very carefully. If there is any doubt at any part, get it noted, and we'll be explaining and clearing your doubts in the next lecture. Thank you very much.